So, next section, we have been looking at the gold medals in the Olympics, where Australia had 46 medals, and it looks like about a third of them each, a third gold, a third silver, and a third bronze. Spain won 18 medals in total, and it looks a little bit, about a quarter were gold, and more than half were silver, and very few bronze, a fifth or something. And then Britain looks a bit like 2/3 gold and quarter silver, something like that. And they got 47 medals. And then the question is, did Great Britain take more golds than Australia? Well, we have to look about what the real number of golds were. We can see that about a third of Australia's 46 gold medals were gold. So Australia, gold, is about a third of 46, which is 46 divided by 3, which is about 9. Okay? Then what do we know for the UK then? Well, UK got 2/3 of 47.
No.
Did they not?
No, it can't be 2/3.
No, 2/5. Sorry, I've written. I need new glasses. About 2/5. So we get approximately 19 golds. So the Brits got 19. Yes! And the Australians got about 9. So the question was, did Great Britain get more gold medals than Australia? Yes, they did. True. On this particular one. Okay, and then we can take the next question. Which did Spain get more silver medals than Australia? Well, Spain got a lot of medals. More than about half of them. I'd say about 4/7 of 18. So that was Spain, silver. Whereas Australia, silver. It looks like we've got about a third again of 46, which is going to be about 15 medals. Whereas Spain, although they've got a lot of silver because they've got so many fewer medals, that actually ends up at being about 10 silver medals. So we have to back up our statement, true or false, with a calculation. And of course it's only going to be approximate because we're only reading off this graph here. So we can say as a conclusion that it would be false, because we can see that Australia took more medals than Spain in this particular case. Okay? About 15 here and around 10 here. Plus or minus a medal or so doesn't matter. Yeah?
You said 9 last time.
Yeah, it was
46.
15.
You said 9. You need new.
That was what we were trying to tell you, but you...
Okay. Yeah, sorry. Yeah, it should have been 9.
No, 15. It's
Yeah,
Australia 15. We were comparing 19 with 15.
Yeah.
And the last one. Yeah, you were right. I'm sorry. I need new glasses.
It's okay.
Okay. Then we have the domino question. Where we have the Chinese Ma Li Ho. Ma Li Ho or Li Hua. She's making the world record in putting up and then knocking over dominoes. She puts up 303,628 dominoes. In 6 weeks, takes her 6 weeks, and she works 12 hours per day and 7 days per week. How many dominoes does she put up per minute? Well, the dominoes per minute will equal the total number of dominoes she puts up divided by the total time that it takes up. And if they want us to do it in dominoes per minute, we need to divide by the time in minutes. So we know that the dominoes is 303,628, and she works for 6 weeks. She works for 7 days in every week, and she works for 12 hours in every day. So her time in minutes will be the 6 weeks multiplied by the 7 days multiplied by the 12 hours, that will be in hours, and so then we need to convert that into minutes as well by multiplying it by 60. That gives us approximately, well, 10.04 dominoes per minute, which is approximately 10 dominoes per minute. When you work that one out. So 10 dominoes per minute to 0 decimals. That was part A. Then they tell you that it took 4 minutes for each domino to fall. So 4 minutes for 303,628 minus 6, because 6 of them didn't fall. 6 of them didn't fall, so we must remember to take that 6 away from the total we got. Okay? That's the number that fell in 4 minutes. Convert the minutes to seconds. So 4 times 60 equals 240 seconds. So if we're going to get the time for one domino, an average, it's going to be the total time for them all to fall divided by the number of dominoes that fell. So we're going to get 240 divided by 300,000 and the 622 that fell, which is going to be 0.0007904 seconds. But we don't want it in seconds because they've asked us to answer to milliseconds, which is sensible because we don't want all of these decimal points in our answer. If we're going to convert any seconds to milliseconds, we have to think, how would we change meters to millimeters, because the milli means the same thing. If we were going to go from meters to millimeters, we'd multiply by 1,000. So if we're going to go from seconds to milliseconds, big unit to small unit, we'd also multiply by 1,000, which means we move the decimal point 3 places, 1, 2, 3, so it equals 0.7904 milliseconds, which is approximately 0.79 milliseconds or approximately 0.8 milliseconds. And I think you can answer either to that question there. But do specify the number of decimals, 0.79 milliseconds to 2 decimals or 0.8 milliseconds to 1 decimal. Right, that's the domino one. And then they moved over to mango trees and orange trees. And if you're going to plant ecologically, I can absolutely imagine that you would put different types of trees in the same orchard, because some insects might not like one particular type of tree and it might keep them away from the mango trees because they might be protected, they might not like the smell of the orange tree. So you can actually do protect your orchard a little bit more by mixing different types that actually scares away insects that don't like the smell or the flavors or that particular or emissions that particular tree gives. So here we have get another coloured pen. We've got figure 1. We've got mango trees. 1, 1, 2, 3, 4. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So these were mangoes. Blue mango. And then around them we have orange trees. So we're just surrounding our mango trees with orange trees, maybe to protect the mango trees. And the same thing here. So in the corner we're putting our orange trees, and then in the middle here as well. So the sensible thing to do here, I think, is make a little table. Figure number, mangoes, orange. In figure number 1, we have 1 mango and 4 orange trees. In figure number 2, we have 4 mangoes and 8 orange trees. And in figure number 3, we have 9 mangoes and 12 orange trees. And then the interesting thing here is not the number, but the interval between each one. Well, what we're looking at here is what's the interval here? Well, here we're going +3, and here we're going +5. So the first thing we notice is it's a changing interval. So it's not a constant that we multiply by n, it's some other form of n. It's either n squared, or it's n times n plus 1 divided by 2, or there's a multiple of n multiplied by another factor of n. And then this one, we can see that the interval here is +4, and the interval here is +4. So here we've got a constant interval, and that one should shout out at you, okay, the sequence here for number n would be 4 lots of n when it comes to orange trees. Because if we went back and took it back to figure 0, we would take 4 off, it would give us 0. So there's 4n plus 0 that we need to add, telling us that our sequence here for orange trees is 4n. Whereas for mango trees, we have to notice, what can we do here? Can we go from 1 to 1, 2 to 4, 3 to 9? It's n squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, so it's going to be n squared when it comes to mango trees. So mangoes will be n squared, and orange will be 4n when it comes to series n. Then it says how many mango trees and how many orange trees in figure 5. Well, that's easy to work out now that we have the system. So mango, when n equals 5 equals 5 squared equals 25 mango trees in figure 5. And orange, when n equals 5, is going to equal 4 times n, which is 4 times 5, which equals 20 orange trees. You can try drawing them, but drawing them takes a lot of time, and there's a big risk that you will actually draw wrongly. So you're better off, at least, if you can't work out this system, just work out what you're doing here. If you added 3 here, 5 here, you're probably adding +7 here to get 16, and then +9 here to get 25. So you can go that way instead as well. And here, 4, 8, 12, and then you can get n, 4 times n. So 4, 8, 12, 16, 20. So you can get it that way if you haven't worked out the series here. Then it says, how many mango trees and how many orange are there in figure n? Well, that's what we've already worked out here. Mangoes is n squared, orange is 4n. Then it says, in figure 2, there are twice as many orange trees as mango trees. work out in which figure there are twice as many mango trees as orange trees. So the way to get that one then is we have to look at mango versus orange. We need to know when there are twice as many mango trees as orange. Well, we don't know the figure number, so we have to have when does n squared equal 2 lots of 4n? When is the number of mango trees twice what the number of orange trees is? We know that n squared is n times n equals 2 times 4, which is 8. 8n. Let's divide both sides by n here to get rid of the n over here. That gives us that one goes and that one goes. So we now know that n equals 8. So when it's figure number 8, there should be twice as many mango trees as orange trees. Let's check. What's n squared when n equals 8? 8 times 8 is 64. Does that equal 2 times 4 times 8 is 32. 2 times 32 does equal 64. So our check works. So in figure number 8, there will be twice as many mango trees as there are orange trees. And then we have the last question, pizza question, which is not dissimilar to a question we did a few weeks ago on the percentage of air in pizza. What do we know? We have a small pizza, and let's say that the radius, we don't actually need the box here. We have a pizza with radius r, and then we have another pizza. So we have pizza 1, and we have pizza 2, with a radius of 20% larger. So if this one is r, then this one is 1.2r. So let's just investigate and see what happens with the area. The area of pizza 1 would be pi r squared. And the area, amount of pizza we're getting for our money, would be pi times 1.2r squared. 1.2 squared is 1.44, so we get 1.44 pi r squared. So what we can see is this area is pi r squared, and this is the same pi r squared here, but it's 1.44 larger, which is a 40% increase in area. The increase in area minus the difference, so the difference between the two divided by the original would give us a 44% increase in area. But we only have to pay 25% extra in price. And it is enough to get all points in this question to answer like that. The area increase is 44%, but the price increase is only 25%. Therefore, you get more pizza for your money with the larger area for a smaller cost. Pizza 2. So make sure that you actually make that final conclusion, and you should be able to get full points, including A quality points for that type of answer.